Hello.
So I think we shall start now. Yeah, we shall start now. It is. It's- Let me share my screen and please confirm whether it's visible or not and my voice is audible or not. Okay. Welcome to the live interaction session on computer integrated manufacturing, which is instructed by Professor J. Ramkumar and Amandeep Singh from IIT Kanpur. So, and this is Chinmoy, PMRF scholar from IIT Madras. So this is about week four assignment session. So I'll be discussing about the questions which are being asked in assignments. So this week's topic is about CNC machine and CNC tools which are being used. So briefly we'll be seeing all those things which are being covered in the lectures. Okay. So basically the thing is that first question was given in the previous year assignment was the CNC machine are designed with precisely crafted tools to aid in production process. Okay, we'll come to the statement later. First, we'll see what are there in the CNC machining process. So, if we see those two animations, we can find one is the left side one is the CNC turning, and the right side one is CNC milling. So, what about those like CNC machining? So, it's nothing but like in as in previous lectures also it has been discussed. So it's computer control process which involves we can say cutting tool to remove. Just a minute, someone wants to join. Okay. So we can say like it's a computer control process which uses basically cutting tool to remove part from the workpiece. Like its basic setup actually involves placing the workpiece on the machine's table and then cutting tools or like which are being attached to the spindle when it rotates and moves to shape the workpiece into the finished product. Okay, so just okay. So then that rotation or movement we can say of that cutting tool, which depends on the CNC machine, which the type of that machine, the level of sophistication. Okay. Anyway, then the actually the process which is very versatile, we can say in nature, and it's we can say it's compatible with various materials also, such as from starting from materials, aluminiums to plastics or wood or glasses, we can say. So this mill part have that high tolerances as like normal machines, milling machines, we can say, which can achieve the tolerance between plus minus 0.001 to plus minus 0.005 inch, we can say. So those this is the basic overview of that CNC machining process, as we can see in the figures or animations, whatever, like that. The so basic steps we can say of that CNC process also itself. So the content is basically divided into that CNC machining center, turning center, then CNC milling or vertical milling machine, then 5 axis and CNC that horizontal milling machine machining centers. Okay, so the thing is that like first the steps of that CNC machining process. So it consists of like preparing 2D or 3D CAD model, we can say. So first, like why we need like 5 axis CNC machining center or horizontal machining center or vertical machining center. Okay, so in 5 axis machining center, mostly like commonly used in aerospace industry nowadays. So it has the ability to tilt the part or tilt itself from the machine. So that function basically allows that machine to smoothly follow a contoured surface. So it easily it can be easily positioned to the tool at various orientation, we can say. So this is the basic usability of 5 axis machining center, we can say. Then comes to the horizontal machining centers. So that horizontal machining center of like CNC machining center or CNC turning center, which incorporates that horizontal spindle. It will allow like you to speed up your production process which ensures that you are not interrupted. So that orientation of horizontal machining centers allows chips to fall away naturally, so you don't have to worry about it, and you don't have to waste your time to clean them off on the table. So for maximum efficiency, you can even set up an horizontal machining center on a pallet while loading that work into separate pallet. So let me tell about that pallet. What is pallet? Pallet is, you must have seen the video lecture there also, it's mentioned that pallet is the work holding device. It can be of angle pallet and and then place plate table which consists of holes. So this is the overview of that horizontal machining centers. And then comes to the vertical machining centers. So it is the setup with vertically operated spindles, which actually tackle workpieces from above and are performed most often on the 2.5 or 3 axis, we can say, machining operations. So it's basically less expensive compared to horizontal machining center, and especially which are attractive to small companies also nowadays. So that's the way actually VMCs or vertical machining centers, we can say, become more advanced or incorporating high speed spindles, and uh, with incorporating that to the control programming part. So this is the basic overview of CNC machining center, where machining center describes almost all any CNC milling or drilling machine which includes automatic tool changer or a table which clamps the workpiece in a place. Okay. So why I'm telling about those things, the first question which is given is that CNC machines are designed with precisely crafted tools to aid in the production process. That statement, from those description, you can even tell the answer, that says statement whether it's true or false. The question is given as, right? So what is the right answer for that? Anyone? The statement is true or false. This is given, right? The CNC machines are designed with precisely crafted tools to aid in production process. What do you think about that?
True, ma'am.
Yeah, yes. So obviously, from that, like the CNC machining centers and the all the types of the centers and what is the working principle of the different types. So we have seen that, like, it it is an advanced manufacturing machine tool, we can say, which performs wide range of machining operation with accuracy and good quality of surface finish. Okay, so even like more than that, actually the orientation of that spindle is even the most fundamental, defining characteristics of CNC machining center, we can say. Okay, so from that point of view, we can say, and we have seen, or like we'll later discuss about that the centers mechanisms which are being used in CNC machining centers. So actually the main aim here is to reduce the production time and gives the to give the best quality results. Okay, so just a minute. It's the right option. Okay. So they are like, if we discuss about that mechanisms which are being used in sensor machining center, which are like automatic tool changing, then automatic pallet changer. That is, pallet is nothing but work holding device, which I am uh, which I told, and then feedback system, then servo motor system, and recirculating ball screw and nut. Okay, those are the mechanisms which are being used in CNC machining center. Okay, later we'll be coming into that point. And like CNC machining centers, which like further basically classified based on the rotation of the at the workpiece or the rotation of the tool as CNC turning machines or milling machines. Okay, in the left side one is the CNC turning machines, which is an emission, gives an emission of that, and the right side one is CNC milling centers. Okay, so basically what does it mean, like CNC turning? So CNC turning is like a precise and efficient machining process, we can say, that works on the principle of the lathe machine. Okay, so it involves that placing the cutting tool against that turning workpiece to remove materials, and it finally gives us the desired shape which we require, right? So that turning center or lathe like stays secured while the raw material rotates at high speed. Then the workpiece which we have placed, that workpiece rotates along that 12 CNC turning machine axis movement, and single point cutting tool which finally that we can see in the animation also, that cutting tool itself it helps to shape the material, and computer programs finally helps to control the turning center or lathe, and it ensures the production of like meticulously that precise components which we are talking about that precision. Okay, so this is the overview of that CNC turning machine. So like how it works basically, that CNC turning. So first we need to have that CAD design. So it converts that CAD design as per our requirement. We need to design it in CAD, and then it converts the file to CNC program. Okay, that CAD design. So the first step involves preparing a CAD file and for formation into the CNC turning machine language. Okay, so that will be converted into the CNC program. Then there is as in the previous lectures itself you have seen that the various softwares about the CAD. Okay, so that CNC then that you have to make sure that the CNC machining process can get pretty dangerous, so you have to make sure that the powers are off. Then you need to like check that part, you need to place the part into the chuck, and then chuck is responsible for that holding. You can see in the figure itself, so it is responsible for holding the part in the place, so while that turning process is going on, right? So those are the basic steps which you need to remember. And then CNC program, if you upload the CNC program, then before starting the operation you need to like upload the CNC code into the machine, and then like you need to keep two variables in mind at that time. Like first one is turning speed, uh, that is basically the speed at which the workpiece rotates, and the second variable is the feed rate, which is nothing but the speed of the cutting tool as like it moves along that rotating workpiece. Okay, so and then like you need to like take care of that CNC turn part, that loading time or cutting time, ideal time, you need to take care of. Okay, so basically, there are some differences between CNC turning centers and CNC lathes. What are those like differences you can identify from that, like CNC turning and CNC lathe? Anyone? Anyone? Any differences you can differentiate between CNC turning centers and CNC lathes? Basically, if we see that lathes are typically like having two axis machines that like have just one spindles, we can say, and but the turning centers can have up to five axis, right, and are for like more versatile in terms of cutting ability. And also lathes do not have that protective enclosure around the machine, and do not have that high production capabilities of turning centers like that. So those are the basic differences between CNC lathe and CNC turning center. But the both of the machines working, like both of them working in the same principle, right?
Excuse me, madam.
Yes.
Yeah, CNC turning center either
Yes.
will have a tool magazine or it will have a turret. A CNC machine, CNC lathe will
Yes.
not have ATC or a turret. That's the difference, man.
Yes. Yes. That's the difference, and that makes you actually more precise and versatile in nature, even in CNC turning, you can say. Yes.
Okay, thank you.
So
Uh,
can I? So I frankly, I am not from the actual manufacturing background. I don't. So can I summarize it like this? In one it's turret, other one is without turret. Is my understanding correct?
Yeah,
Yes.
you can say in this
Can
term
I
also.
can I talk? Can I talk?
Yes, 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 sure.
Yeah. Generally, since I am from the CAD CAM area and CNC machine area, I'm just enthusiastic to talk. Okay.
Yeah,
Okay,
yeah.
sir. Yeah.
Yeah. The difference between a CNC machine and a machining center. The moment you use a machining center, it will have a tool magazine. Automatic tool changer will be there. If there is
Okay.
no automatic tool changer, it is only a CNC machine, like CNC lathe, CNC milling machine, like that. Okay.
Mm-hmm.
In
Okay.
respect of lathe, either you will have a turret or some machines will have the tool magazine also.
Okay. Okay.
Okay.
Okay. Yeah.
Okay,
Thank you,
madam.
sir.
Hmm.
Yeah,
Thank
yeah.
you, sir.
Okay, sir.
Okay. Then, like moving to that CNC milling part. So it's as I have already talked about that in previous slides, that whatever that CNC milling machine. So it's nothing but like similar way in computer control process, like involves that cutting tool to remove part or workpiece, and that basic setup involves the placing the workpieces on the machine tables while cutting the tool, or it attached to the spindle rotates and moves to shape the workpiece into that finished product. Okay, so that rotation and movement of the cutting tool actually depend on the CNC milling machine type and the like that process actually. Yeah, as we are talking about the CNC machining part, obviously it's versatile and compatible with various materials, right? So that first the same steps are being followed in CNC milling process also, from starting from preparing a 2D or 3D CAD model as per our requirement, like some technical drawings given to the operator, such as you have to have that critical features or dimensions of the part you need to mention, and the tolerances and the trades or like finishing part, preferences or construction lines, those you need to mention in your CAD design as per your requirement. Then export your design to CNC compatible file format. Okay, so that machine won't understand the model you design, right, in CAD file, unless it is in compatible CNC machining file format. So that's the reason actually you need to export your CAD model into CNC compatible file format with the CAD CAM softwares. So that you must have heard about STL file or STAF file when you like export some design CAD file to CAM softwares. Okay, so that like that machine milling machine that after that the operator will attach the cutting tools to the spindle and the place that workpiece which you will provide on the table. They will then set up the machine to initiate the machining program, and it will start the milling operation. Okay, so basically there are different types of milling we can see, like face milling or plain milling, then angular milling, or other types like slot milling, side milling, those kind of things. So basically, like it's like same steps they are following in like each operations. So this is the overview of those two milling. Then horizontal milling centers and vertical milling center we have talked about, right? So now coming to that CNC tools. So the concept of that computer numerical control incorporates wide range of that machines which performs various functions, like designed with precisely crafted tools, which we have seen here. So basically the tools performs precise cuts on metals, woods, steels, aluminium, and variety of materials we can see, right? So that multi-axis cutting tools can move in very many directions, or enabling that most precise cuts possible on that materials at a glance. So like if the question number 2 shows that multi-axis cutting tools can move in, fill in the blanks. There are that one, two, three, or many. You can easily tell about that option, right? What is the correct option for that?
Many, ma'am.
Yes. So that option D is the right answer for that. Okay. So that like cutting tool serves one purpose to cut through that material, but in they are like different purposes they solve actually. So for cutting tool to be effective is it has to have 30 to 50% harder than the material it will work on. Okay, so the workpiece material what you have chosen for like milling or some like machining operation, for that your tool need to have 30 to 50% more harder than the material you choose for your workpiece. Okay, and like have to have high thermal conductivity. See, 70 to 80% approximately of that heat goes by the chip, and like 20 to 25% it goes by tool, and 10 to like 5 to 10%, or you can say it goes by workpiece. So you can see that the tool takes that significant heat portion from that, so it has to have high thermal conductivity, right? So that's the reason the tool which you are which will be like that for cutting or like machining operation, so it has to have high thermal conductivity, and together like it has to have low coefficient of friction, then it should be resistance to wear, and it should be chemically inert or stable. Okay, so and the most important thing also, the tool material has to have chemically inert and stable and at high temperature resistant. Okay, so those are the those are the few like specifications of that cutting tool for effective workability, we can say. So to like one question is given that for a cutting tool to be effective, it has to be 30 to 50% softer than the material it will work. So the right option for that, anyone? Is it correct
It's
statement or
false.
yes?
Exactly opposite.
Yeah, yeah. So that 30 to 50% it should be high like harder than the material it will work on, right? So the right option would be option B. For a cutting tool to be effective, it should have obviously it
High
should yeah,
high
high
thermal
thermal
conduct.
conductivity. So the right option is A. Okay. Yeah, which of the following properties should be present in a cutting tool to be effective at cutting? So what is the correct option for that?
Should be chemically inert and
Inert.
stable.
Inert.
C. C.
Yes. So we have seen those properties for
Hmm.
effective work of that tool. So from that itself, we can tell that the option C would be the correct option answer for that. Okay. So now coming to that, can you please, can you anyone can tell like some of the cutting tool material which are being used to like manufacture the cutting tool?
Cobalt, nickel.
Yes.
Titanium. I'm not sure. Huh? Just I've heard titanium
Yes,
or
titanium
not.
is also
Yes.
used.
Yes.
Titanium is also
TIC.
TIC or
Yes.
TIN, titanium
Yes.
nitride.
Okay.
Yes.
Okay, sir.
Tin coated inserts are available.
Yes.
Okay, sir.
Uh,
Even high speed steels are there.
no,
Okay.
above high
Yes.
Okay.
speed steel is the carbide and the
Yes.
ceramics.
Yes.
So,
So
sir, just I want to know, even so, the out of this, uh, means I can see like high speed steel is there, cemented carbides. These carbides I have heard, but ceramic, is it used or is it
Ceramic is very
misfit in that?
ceramic is
it's
very expensive, ma. That's the
Okay.
reason we always in the industry we
Okay.
use carbide tips rather than ceramics because it's too expensive because
Okay.
you
Okay.
will
But
not
is it,
get.
sir, is it wear resistance as mentioned or
Yes,
not? It
yes, it
is.
is.
Okay.
It
Okay.
is. It is. It is.
So my question is, so for this number six, all four are correct answers. I'm a bit surprised.
Which of the following cutting tool will has greatest wear resistance?
Greatest. Okay. So
Greatest
one
wear resistance. Greatest
greatest.
wear
so
resistance is either
ceramics on
ceramics,
ceramics.
even to
Yes.
some extent coated carbides also.
Okay. So ceramics. So D is the answer, na sir?
These answers.
Yes.
Okay. Thank you,
Yeah,
ma'am. Thank you,
yeah,
sir.
yeah.
if you like plot a graph of that, like you can find there. So if you plot like between wear resistance and that hardness,
Okay.
so you can find that here you can plot as HSS or high speed steels, and the position of that ceramics will be in that place. So
Okay.
from that plot itself you can tell that ceramics is having that highest wear resistance as
Okay.
being a cutting tool material.
So
Okay.
you said, ma'am,
Yeah.
you said X is where and Y is what? Y
Hard.
axis?
Hardness,
Yeah,
hardness,
Hardness.
hardness.
Okay,
hardness.
sir.
Yeah.
Okay. Thank you,
Pardon
ma'am.
my like writings or like that. It's
No, 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 it's all right. But now it's clear.
yeah.
Wearing and
Oh, yeah.
hardness. Yeah.
Wear
Thank you.
resistance and
Wear
hardness.
resistance.
If you yeah.
Perfect. Thank you.
So, like similarly, if you can like see that toughness, how it varies to like, and that material to toughness. So it is like if we compare that toughness to like from the, if we vary the materials to the toughness, so we can see that from that high speed steel, I guess it's having the highest toughness with respect to other, right? Am I right or wrong? So high speed steel should have the highest toughness compared to the other materials, like other which are cutting tool materials which are being used. So and then we can even like compare with that hot hardness to that toughness itself. So those are the properties which are being like mentioned, we need to consider about while like choosing that cutting tool material, its toughness, hardness, and like wear resistance, those the properties. So the next question even it's there that which of the following cutting tool materials has the greatest toughness. So if we plot a diagram as that is material, or this is the toughness property, if we put it in y-axis, then this is ceramic. Okay, then above that we can place coated carbide tool. Okay, or we can say carbide tool above that, cemented carbide. Okay, and above that if we place there, then we can say HSS, high speed steel. Okay, so from that plot itself we can tell that the high speed steel is having the greatest toughness with respect to the other materials which are being used in cutting tool material. Okay, so the right option is high speed steel. Then the next portion, like those are the part like that, the hot hardness, or we can say that hardness. So basically if we tell about high speed steel, or like it's composed of high carbon steel with reasonable amount of element alloys like chromium, tungsten, or molybdenum. So with this combination actually it improves the hardness, wear resistance, and toughness. Also it provides high material removal rate for if we want to cut some metals or like other materials, then we will see that we'll see the high material removal rate from that cutting tool. Okay, so to improve that property, like certain surface treatment also are there in like for HSS. So this property actually allows HSS to cut faster than high carbon steel. Okay, so that's the reason it's like named as high carbon steel or like high speed steel, sorry. So that steel actually to be in that manufacture of various cutting tools like drills, taps, milling cutters, tool bits, then gear cutters, hopping or saw blades, then planer and like bits and joiner blades. So those kind of application this high speed steel is having the usage. Okay, sorry. And also there are ceramic cutting tools or cemented carbide. Then ceramic cutting tools like constructed from mainly alumina or Al2O3 and silicon nitride. So that have also introduced that use of silicon carbide and ceramic matrix composites. So it actually that we have seen from the plot itself that it exhibits that excellent hardness, toughness, and thermal conductivity. So what is the advantage of using ceramic materials? It actually revolve around ceramics' greater ability to withstand much temperature than the tools made from the carbide or high speed steel. Okay, so that's the reason actually, if we in term of hardness, if we compare, then the it's having greatest hardness rather than other materials. Okay, so like usability of that select ceramic cutting tools, like it is being used at highest cutting speed or recommended, and to square or round inserts with large nose radius, then machine rigid workpieces serving machine like used, then uh, that negative like rake angles also, if we see that, if we have studied in that metal cutting or portion, then we have seen that it provides that negative rake angles also, that less force which is applied directly to the tip of that ceramic cutting tool. Okay, so those are the basic parts of that tools. Or cemented carbide, if we say, it's like a hard material which use that extensively cutting tool as a cutting tool material. In past also we have seen that. Just a minute. Okay, so it even withstand that higher temperature at the cutter workpiece than the standard high-speed tools also. So those, and it choose the grade with lowest cobalt content, and then like finest grain size consistent with that adequate strength to eliminate that chipping. Okay, so and that tungsten carbide grades, and then that heavy cuts in steels where high temperature and high pressure deform the cutting edge plastically. So these are the like some of the advantages why people are using from long ago that cemented carbides as cutting tool. Okay, so and then comes to that which of the following cutting tool has the greatest hot hardness? Okay, so from that, what will be the right option for that? Anyone? We have seen the hardness graph, right? It should have,
Ceramic,
yes, ceramic
because
should,
it is on the right topmost right on in that graph.
yes. So, and also we have seen the usability of the ceramic cutting tools, right? From that itself, we can say that it is having that like and also that one like the advantage of that is that it uses that negative rectangle, so less force is applied directly to that ceramic tip. So and like moreover that it takes like a large radius, more radius, and side cutting edges angles on the ceramic insert. So by like those are the few of the usability or advantages, we can say, of the ceramic cutting tools, okay, which are being used. And which of the following elements are present in high-speed steel? So this should be like, we have seen that in high-speed steel also, like the component of that high-speed steel, right? Chromium is there, yes. Tungsten is there, yes. Molybdenum is there, yeah. We can say, right? All of this it should be, because cemented carbide, in high-speed steel, we have seen that the materials which are comprises of that chromium, tungsten, molybdenum, both of them three. So the right option will be all of these, right? Yeah, it should have all the component. So like by this combination making, like it as it is combination of chromium, tungsten, and molybdenum alloys which are being used. So by this combination itself, it improves that hardness, wear resistance, and toughness, and also it offers that high removal rate from for metals, right? So that is the lexane. It's a reasonable amount of elements or alloys are being used, which are comprised of chromium, tungsten, and molybdenum. Okay, so can be made of which of the following tools can be made of high speed steel?
All of this.
Yeah,
D.
yeah. Okay. So the basic thing is like if we say the coding also ISO coding, anyone is having any idea on ISO coding system on tungsten carbide inserts? Especially those are being used in turning, right? The tungsten carbide inserts. So can anyone explain that?
There are uh, like SVJBL, SVJBR. Like, see, basically the tool holders have got ISO code,
Yes.
and also insert also has got a code. DNMG 040408 is
Okay.
a insert. The inserts could be maybe around a 30-degree, 45-degree, then 60-degree. Hello.
Hello. Yeah, yeah. You can continue.
Yeah, so the inserts has got ISO code, and the tool holder also has got ISO code.
Okay. So what is the significance if we say like of that ISO coding system?
No,
So
otherwise it's a standardization
yes.
across the whole across the world. So nobody, everybody understands what is SVJBL, what is SVJBR, what is DNMG insert. If somebody says DNMG insert, everybody understands that. It's a
Yeah,
ISO code accepted everywhere in the throughout the world.
correct. So if I like just a minute, for example, if I write those like terms as T, so in insert like the T represents that insert shape, because in your assignment question, one question was given as if I mention that question as just a minute. Okay. Yeah. So maybe that's like yeah, SBGG220615. Just a minute. Let me write that. Okay. SBGG220615. Okay. So from if we like put this question as like that that code is given, right? SBGG2206165. From this ISO coding for tungsten carbide insert used in turning, determine the shape of the insert. So by seeing that, like you need to have that understanding that okay, that term that code, from that code itself you need to tell that the shape of the insert, right? So for this, that you need to have that understanding of on that ISO coding part. So T, which represents that insert shape, so where like T is the triangle, S squares, then
Square.
yeah, R represent round. Okay, so
Even
C,
C is a circle. Okay.
yeah, C when diamond 80-degree, or D is diamond 55-degree, diamond insert if you say.
Yes, yes.
V is diamond 35-degree. So those are the basic shapes which you need to remember like every words as that significance, right? Here it meant the first word is given as S. So what will be the like for S the significance is square, right? So like immediately we need to define that, okay, the shape of that insert should be square, right? Yeah, so that S.
Uh, can you please once again repeat all important? S is for square, R is for round.
Yes.
Then, ma'am,
S.
diamond. What did you say?
Yeah, C represent diamond at 80-degree.
Okay, okay. C is for diamond. Okay,
Yeah, and D also is for diamond 55-degree.
okay, okay. Yeah.
And then V is diamond 35-degree. So 80, 55, and 35.
Okay. So C, D, and last one, the last diamond you said is V.
Yes.
Okay, okay.
And T is the triangle.
Triangle.
Yeah,
Okay,
triangle
clear.
shape of insert. So those
Okay.
represents the shape of the inserts. Okay. Or say then if you like see N, or here it is given as B. So this is the like N is the insert clearance angle. Okay, so N here, N if it's like represents 0-degree like yeah, 0-degree clearance is given. Okay, or here T is triangle. Here N means 0-degree tolerance. So here B is given. B means that like 5, the tolerance limit is, clearance angle is 5, sorry, clearance angle is 5-degree. Okay, or say C, if here itself like C is given, then C you need to like sorry yeah, you need to mention that 7-degree clearance angle. Okay, so those are the like significance of that. N means 0-degree clearance angle, insert clearance angle. Okay, then comes to G. Here G is given. So here G represent the tolerance. Okay, so T first word represents T or S, whatever it is, it represents the shape of insert. Then the next one it's representing clearance, insert clearance angle, that can be N, B. So any doubt? Okay. So here the next one is G. That G actually it's representing the tolerance. Okay. So G, M or U basically is being used 0.001, 0.002 or 0.005. Okay. G, M and U. So thus that represents the tolerance limit you have to mention. So then that G is given, and then G is that insert type, like with hole or clamp on with chip breaker or hole and special features, you can say that again is given as G. So that is the insert type, that means that clamp on with the chip breaker. Okay, so and then 22 is the cutting edge length. Okay, so and the 604 06, that is the insert thickness. Okay, the 22 represent cutting edge length, 04 represent insert thickness, and 165 yeah, 165, that is the nose radius. Like 16, it should be like that nose radius if we define as it's between like various regions 2 and 4, like that the regions are there, so that is the nose radius regions. So that is the significance of each word in ISO coding. Say for example, you that code would be provided to you in questions, so you need to mention that according the question that in tungsten carbide insert, tell me that the shape of the insert by showing that code, ISO coding. So that's all about that ISO coding system. And also that,
Ma'am, sorry, just last one you said. Uh, so S is clear. B is for insert clearance angle, right? And then
yes,
third one, my first G is for tolerance. Second G is for insert type.
yes,
Then 22 in that is
yes,
cutting edge length.
Yes.
0.6 is insert thickness, then this 165 is
Actually, that 1 6 or 6 5 should be nose radius.
okay. Okay. So,
That
yeah, nose radius. Okay.
yes, if we like draw that tool like that, so this nose radius is there, right? So this should be mentioned
So,
as
ma'am, if we see the upper example which you have taken,
yes,
that is 2204 and 08. So, in that case, 08 will be nose radius. Am I correct?
yes, 8 mm.
Okay.
Yeah,
Okay. Okay.
yeah.
Thank you.
Okay. So those are the basic like questions, or say in one of the example, like in one of the question you have also
Point
seen.
m point 0.8 mm radius.
Yes, 0.8 mm radius. Sorry.
Yeah. Yeah.
Yeah.
I'll be correcting some. You should not mistake me. Okay.
No, 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 no. It's
I am
correct
from
actually.
the industry. Okay.
Yeah, yeah,
Uh,
yeah. It should
yeah.
actually by mistake I have seen. So you can even tell that wherever I.
Yeah. Please don't mistake me.
No,
Huh?
no, 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 no.
Yeah. Yeah.
It's
Huh?
okay. Yeah.
Yeah.
It's more about a discussion class, so it's better like if we discuss among ourselves, so it will be like the doubts will be cleared. So it's good only that you are telling the points. So not an issue. So in like this time to like that assignment question, one of the question also is given as that uh, okay, ceramic materials can withstand temperature. Like one fill in the blank is there. Then the tools made from carbide or high speed steel. So ceramic materials can withstand high temperature rather than the tools made from carbide or high speed steel, right? So, and one more question is there, that which of the following elements are used for the construction of ceramic cutting tools? So, L2O3, yes, L2O3 is that used for like ceramic cutting tools is being used, alumina, or silicon nitrate, silicon carbide, we have seen that SiN. So those are the correct options, as you one of you also have mentioned about that, nowadays like those are silicon nitride and alumina are being used as as materials in ceramic cutting tools making. So that both of them are the correct option. And one of the assignment question was given as carbide tools can withstand high temperature at the cutter workpiece interface than standard high speed steels.
Actually,
Yeah,
no. There is no display, madam. Hmm.
no, actually this year assignment questions, this time assignment, those are the previous year questions which I have mentioned. Like
Okay.
those are the other questions which are being there in the in this time assignments. So those I am now discussing about that. Okay, so though apart from that, I guess that other questions are being there from that part only, that lecture parts only. So, in any doubt on this, like you can ask questions, or if I like, I'll try to answer the questions, and if not, then I'll try to like find the answer in next class. So any doubt on this? Like this is the main overview of that lectures note of on that week 4 and the assignment overview that are being used in like that are the overview of CNC machining center, turning center, or milling center, whichever in the previous part, and then the tools which are being used in CNC machining. So, and from that only that questions are being designed. So, any doubt on this?
So, ma'am, even in main question paper, that is
Yes,
final when we go for that proctored exam,
yes,
it
yes.
is MCQ only,
That
multiple
actually,
choice.
I don't have any idea. That
Okay.
instructor only can provide.
Okay.
Yeah. So, apart from that, any doubt or any questions?
Madam, while explaining the
Yes,
milling and turning,
yes, yes,
showing that displays, na? Hmm.
yes.
Yeah. Then you said it makes an accuracy of 1 micron.
Uh,
So generally,
yes.
it's not possible. No, it's will be around 10 microns. It's very difficult to achieve 1 micron.
Act.
Generally, in a jig boring machine, we'll get around 5 microns.
Yeah.
Any CNC turning centers, we always get around 10 microns. Okay, I'm
Okay.
talking about practical. Okay,
Yeah, yeah. Actually, if you go for the real-time applications or real-time operations, you can't find. But maybe in micro milling, CNC micro milling, you can find like an 1 micron accuracy. Though I'm not
No,
sure.
no, ma. You will not be able to do it. The reason is, if you look at the specification of a CNC machine, if
Yes.
you look at the accuracy and the repeatability, you will come to know. Okay.
Okay.
So generally, any CNC machine, it's around 10 microns, and any jig boring machine is around 5 microns. If we get into microns, then it will be
Yes.
grinding or honing like that.
Okay.
Okay, Amma? Hmm.
Yeah, yeah.
Hmm.
No, actually, presently also I'm like doing some work in micro milling. So I'm like actually doing some texturing on that. So I'm trying to find that like accuracy with that. That's the
As far
reason.
as the CNC machine is concerned,
Yes.
it's very difficult to
Yeah, yeah.
build a machine with only micron accuracy. Ma?
Actually,
So
okay.
my question to both of you is, let's say, so is it a stepwise thing? Like if you want to have in Micron, first you do CNC, then the next maybe for jig boring, and then the final finishing kind of thing in what you said, the third
Grind,
one,
grinding.
grinding.
Grinding or
Is
honing,
this so? Is this
grinding
a
or honing.
stepwise process? I want to know.
No, 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 no.
Actually,
It
no.
depends.
It
No,
depends
excuse
on
me.
your requirement. Actually,
It
I feel.
depends on your drawing.
Yeah.
Basically, it
Okay,
depends on what is the tolerance he has given in the hole, or he has given
okay.
any feature, whatever the feature he has given. What
Mm-hmm.
is the tolerance given on that? It depends on that. Ma.
Okay, so for example, let's say in automobile industry for most of the things you won't require that high unless it's like something I'm asking this, I'm not sure, I'm asking is it correct, is my so for automobile industry, let's say something inside spark plug or something where you want to, or some fuel injector where you want to micro control and do something, will that be the fit case for that kind of micron kind of control, or no? Where is it used, that kind of micron? Fine.
Basically, it depends on the end usage. One is end usage, and another one is your joining mechanism. Supposing some
Okay.
joining is there. For example, bearing is there. Bearing will always be very precise. No,
Ha
very
ha ha.
precise.
Yeah,
No?
yeah.
Bearing will be very, very precise. General components, which are, I will say, non-rotating type. Generally, non-rotating type will be of a medium
Accuracy.
accuracies.
Okay, okay,
Very
okay.
closer accuracy. You can always take like this, whatever I am saying. Okay. Rotating type of components will always have a very tighter accuracy
Okay.
because it will give imbalancing. Na? Hmm.
Ha ha ha. Okay,
Okay.
okay, okay.
And also depends on the type of your matching. See, if you have another matching component or a joining component, so
Hmm.
that also this tolerance matters very much in the joining.
Okay, okay, okay. Okay, sir.
And
Thank you.
basically, whenever we based on the component
Mhm.
drawing, we have to select the machines.
Okay, okay.
Whether
Yes,
we
sir.
have those machines or not, or we have to get it outsourced. All those decisions have to be taken. And one more thing, basically, when you, madam was saying something, I want to add something. Okay,
Yes.
basically, when you have a drawing, you make actually you create a CAD. Okay, I mean, model actually, drawing model. Once the drawing model is done, you have to arrive at the material. What material and what material size. So once you have the material size, next step what we call it as process. Process is nothing but sequence of operations. Once we have the sequence of operations, then what each operation or what each sequence has to be done, we decide. Then only we make the program and then it goes to the CNC machine.
Okay,
Okay.
okay. Yeah, yeah, yeah. Clear. Thank you,
Huh?
sir.
Okay, no mention. Madam, I am just trying to add. Okay.
Yeah, yeah, no, no issue.
Okay.
Actually, you are
Since
having that
I
industrial
am helping you.
experience.
I am
Yeah,
because I am a basically I am 61 years old and with lots of manufacturing experience.
And you are having that industrial experience. Actually, it's good to have that practical or like real life application. We are everything we are reading in books, and then we are reading papers.
Yeah.
Accordingly, we are working. So that much like real time experience we don't have. That's the reason. Like
So,
yeah,
and these days, the CAD CAM system is so much uh, the improvements
advanced.
have been
Yeah.
advanced,
Yeah.
wherein if you have the component drawing, they can arrive at the process also, the sequence of operations. So
Yes.
that
Yes.
much actually that much intelligence has been built.
Yeah. Sure.
So based on that, each operation probably we can make the connected transfer it to CAD, I mean
Cam.
CAM, and then make the program on that.
Yes.
Do you also talk anything about agile manufacturing and uh,
Those are being like discussed
that
in
will
the
not discuss? You will not discuss
no.
that. Okay.
No, no. In
High
agile
speed
manufacturing,
machining, high speed machining.
those are the things like are being discussed in the previous first class, introductory class, in like
Okay,
briefly.
okay,
Those
okay,
are
okay,
being.
okay, okay. Actually, while saying about the thermal conductivity and other things,
Mm-hmm.
you should have made a mention of coolant. Coolant takes away maximum heat actually.
Yeah.
To cool, because I didn't hear you saying that. Basically, when the cutting happens, in some cases it will be submerged. For example, if you look at the titanium,
Mm-hmm.
we always use a flood coolant. The reason is uh,
It is reactive, no?
hardens.
Am I
It
correct?
work hardens. It work hardens. Okay. Basically, when you do the metal cutting, if there is no coolant, the titanium tends to work harder. Okay.
Yeah. Even after machining, also that titanium, you will see some burning phases in your workpiece material itself. You can see some burning colors that due to that heat, like produced
No, no,
while.
but generally, in aircraft industry, when we do the titanium misting, we
Mm-hmm.
always use flood coolant. Generally,
Mm.
that discolor, giller, and all will not allow that.
Yeah, yeah.
Only the coloring and all will happen sometimes
Mm-hmm.
when you do the uh, welding.
Okay.
Hello. Yes, ma. Can you hear me?
Yeah, yeah.
Yeah. Basically, the coloring and all I see only when you do the welding.
Mm-hmm.
Machining, we don't get the color. If it happens, the color happens, then we may have to reject the component.
Yeah.
So generally, flood coolant is used in titanium machining. Okay, Amma?
Yeah, yeah.
Hmm.
Anything else from that? Actually, the thing is that we need to discuss some that previous year assignment questions among ourselves, and we need to discuss that like a live interaction session kind of thing. Whatever
Sure.
the doubts we need to interact. So those are the questions that were made in the previous year assignment. So I tried to put as much as possible so that we can cover it in like that class. So anything if I need to add, you can mention. Then from the next class itself, I can try to add those things. And anything else from that? Otherwise, we can close for that today.
Okay. Thank you, madam.
Yeah.
Thank you, sir. Thank you. Bye.
No mention. It's pleasure interacting.
No, no,
Thank you.
it's good actually. That interaction
Thank you very
session
much.
Basically,
actually.
because you're all from academics, whereas
Yes.
I am from the industry, and
Yeah,
uh,
yeah,
and I am a now retired person, so I can always be
Thank you. Thank you.
talking. Probably I
yeah,
can give much more information also.
yeah,
Thank
yeah.
you, sir.
Thanks for giving
Bye.
that information itself.
And I have not attended any class actually. This today is the first day I attended.
Okay. No, it's good actually. We got to learn so much things, so it's good.
Yeah, it's no problem. I always love to share.
Yeah. Okay.
Okay, ma. Good day.
Yeah, but